Hello. Welcome to the show. We're going to talk about GitHub Actions today. Again. Yes, again, GitHub Actions. It's all I talk about lately. It's just, there's so much going on. We're going to talk about security specifically. I've done this on the stream a couple times over the last year, but I feel like I need an even shorter way to help you make sure like the top 3 things you shouldn't do in GitHub Actions are being avoided. Like basically those things are being avoided, those bad habits. It seems like a lot of open source projects have not done this lately. So we're getting a lot of news about various attacks and attempts to thwart the security boundaries of what we thought open source on GitHub had. And it turns out people running GitHub Actions maybe don't know all the right settings. And depending on whether you're making open source or closed source, the defaults might not be the right choice. So I'm going to walk through some very specific examples, and then if I have time left today, I'm working on a scanning tool that at some point it will be, I'm not sure if it's going to be a web service or if it's going to be a command line tool or if it's going to be free or what, but there's like 5 or so obvious things you should be checking in all your repos to know that settings are set safely for open source repos. And I check these on every consulting gig or every repo that I make. I'm always in there checking to make sure these things are set up. And then sometimes it's not set up properly in old stuff, and the old stuff needs to be fixed. And maybe, I'm not sure, but I'm trying to make this tool that will automatically just set them to what you want in bulk. So if you have 100 repos, it's a very tedious process to go through the settings of 100 repos. If you just realize, oh, I've got this setting wrong for GitHub Actions that somehow gives people a potential attack vector, well, good luck spending all your days going through 100 repos and checking them and then setting them. So I'm pretty sure with the API, we can monitor these settings and check them. So I've got Claude over here on the side actually working for me right in the moment. And if we get some time, I'm going to see how far I can get with it. It says it has a tool ready to go. We haven't tested, so we'll see what it requires. Yeah. So in chat, I need to throw a question in chat. Can I throw a question in chat? Let's see how. Oh, it's down here, I think. Start a poll. Okay. So, which code automation platforms do you use primarily? Primarily, primate. Okay, so it looks like you can only choose one of these. Okay, so we're going to say GitHub Actions, GitLab, Azure DevOps, Jenkins. Oh, is that the only? I can only make 4 choices? All right, so I'm starting a poll. I don't do these very often. I'm kind of rough at it. Actually, I should move this window right there. Yeah. Okay. All right, so I just realized I don't have my glasses on. That's why it's blurry. Hi. All right, so let's talk about it. What are we talking about today? We're talking about GitHub. And specifically, how you can keep yourself safe. Ironically, a lot of the headlines, I'd say a lot. I'd say there's been headlines over the last year that I've been tracking and you've been hearing about on this show related to maybe the defaults in GitHub or the way that you've previously set up your GitHub aren't ideal for open source security. And so now, with the rise of AI, I feel like we're getting more attacks on supply chain. Supply chain has been the trend. As we maybe get better, and maybe this is an industry trend, and I don't know, I'm going to speculate here for a second, that maybe as we're, instead of attacking live systems and then hoping to tunnel your way through, which usually requires very specific targets, then maybe let's attack the supply chain and figure out how to get our vulnerability or our exploit in the code on its way to countless other open source projects or closed source projects. And then, maybe we can hide our tracks better, or we can make a bigger hacking impact on that. Like maybe there's something like that that's going on. I don't really pretend to understand it's always money. It's either money or reputation, I would say, the two primary causes for hacking attempts. But in open source, we traditionally haven't had a lot of successful exploits of the supply chain that are publicly launched in terms of industry-wide attacks that are successful. But I feel like we have had a growing number of that over the last year. And because the home of open source nowadays has been GitHub for many years, that becomes the primary target, right? So GitHub is being picked on a little bit here, that they're taking the brunt of the attacks. And one of the ways that has become quite successful over the last year is misconfigured GitHub Actions. And I will say misconfigured because I think whether it's Singularity or it's Shai-Hulud or this latest HackerBot Claw, they're all like that's at least 4 major attacks over the last year that I'm counting there, and I'm probably skipping other ones. The Singularity one was primarily focused on NPM, but I believe in all these cases, their primary entry point was through GitHub Actions. And we've seen this before with the XZ attacks in the past. I'm trying to think, that was probably a year ago. That wasn't even a year ago, I don't think. Where those weren't using GitHub Actions, but those were using, I would say, social engineering. In this case, we're seeing increased amount of attacks on open source where someone plays nice for a couple of years and then they're able to take advantage of something. So we're gonna need to write these down. I'm gonna actually approach this from. Let's approach this from. We're gonna make a new one. I'm gonna call this GHA attack. Oh, by the way, did you know I'm making GitHub Action courses? Yeah, I'm in the middle of, we're actually in the middle of early bird launching. If you go over to the wait list, we are launching the very beginnings of our first course. By the way, MF Tuna, I'm guessing you're Mark, but yeah, DM me. Good to see you on the show. Hello, everybody. Tyrash, maybe is that Tyrash? Is that how I say that? Sorry if I mispronounced. Hello to everyone on the stream. All right, so I just realized I didn't tell my people on the membership. All right, I didn't tell people that they should come and join the show. I forgot to notify my Patreon fans and my YouTube members. All right, they'll figure it out eventually. All right, so sign up here. This is GitHub Action courses, starting with all of the basics and moving into AI in your LLMs, inside of your actions, like agents inside of your pull request, inside of your repo. How do we auto detect, GitHub Action run issues? How do we manage more of the toil of GitHub and open source and closed source software? How do we do all of that? So those are all courses that are coming. So sign up there if you're interested in a discount or in the launch details for that. I put that in chat. All right, what we're talking about here is common GitHub Action attacks. I'm going to say attacks. So the first one we're going to talk about is this new one, which is pull I'd say this is number one right now, the pull request target event. We're going to talk about that first. But another one is social engineering via, what are we calling this? Default external. We're going to have to look up the name of this thing. Okay, I need to turn off Grammarly. All right. Default external contributor. And then these are actually the most common two. There's another one. Auto run actions for fork PRs, which is another one that we were going to talk about. This one actually was used, I believe, last year in the Shai-Hulud attack. It also might have been used in the Singularity attack. This one was used, I think, in the XZ attack. And this one is increasingly being used because it's really easy to scan for repos that have it, because this is inside of your YAML file as a string in a YAML file. So if you have this, you're immediately at risk. So it's easy for the hackers to scan for it. All right, so we're going to go through this stuff one at a time. And these are things that are essentially, if you were to hire me to lock down your GitHub, these are 3 things I'm going to specifically be looking for day one. And if you have any of these, we are going to either turn them off, change the setting, or we're going to look at mitigation tactics, or at least at risk of what you're potentially at risk for if you have this enabled. Because these are all things that are just settings or features of GitHub that are improperly configured inside of your repos. So not necessarily GitHub's fault, although we could always argue that they could do more for education. They could indicate risk when you're changing settings, especially if it's an open source repo. They could say, hey, by the way, when you enable this, you're adding this risk. Click here for more information. I'd love it if they'd give that kind of detail in the settings pages, but that's currently not the setup. And we're going to use, let's use one of my recent examples as the repo to look through. So this is a repo for a whole, I just had a blog post and a YouTube video and a podcast come out called Silent Rebuilds. If you're interested in that, where should I send you? I'm going to send you to the link tree, because this is like, depending on whether you want to listen to it, watch it, or read it. I think it's start. Is it start page? Yeah. All right. So this will give you all the links to get all that stuff. So, will these notes be available to us after the event is done? Sarah Abada, that's how I'm going to say it. This live stream stays here, so it's not going anywhere when the live stream is done. If you're on YouTube, if you're watching this on YouTube, which looks like you are, yeah, it'll be here. And specifically, most of the stuff that I talk about is in various repos or in blog posts on my website or in other YouTube videos. So absolutely, this is staying here. All right. So let's go. I'm just going to read through this real quick. It's a pretty short article. And we're going to skip around. I'm going to throw some commentary in there. So the HackerBot Claw, the title reads HackerBot Claw Bot exploits GitHub Actions CI/CD flaw to attack Microsoft and Datadog. So this is like all titles in the headlines. It's a sensational one. It is not a GitHub Actions CI/CD flaw. It is simply a feature that shouldn't really be used. So there's very few cases where it needs to be used, and most of those are not the cases that people are using it for. So we just need to do a better education. All right, HackerBot Claw, an autonomous AI bot, has launched a week-long campaign against GitHub Actions misconfigurations to hit CI/CD pipelines at Microsoft, Datadog, and other major open source projects, achieving remote code execution and even full repo compromise in some cases. The attack highlights how unsafe the pull request target workflows and shell interpolation bugs can turn routine automation into a supply chain backdoor. The account advertises itself as an autonomous security research agent powered by Claude Opus 4.5 and maintains an activity log of its profile. Over 7 days, the bot did 3 things. 1, targeted at least 6 high-profile repositories, including Microsoft Datadog, Aqua Security, CNCF projects, and popular tools like Rust, Python, and Trivy. The second one is they opened more than a dozen pull requests to trigger CI workflows and validate exploits, and then achieved arbitrary code execution in at least 4 repositories and exfiltrated a GitHub token with write permissions from a top-starred project. What are top-starred projects? I guess just popular projects. Between the 21st of February, 2026, and 28th of February, the GitHub account HackerBot Claw systematically scanned public repositories for exploitable GitHub action workflows. The attacker injected a Go int function into the quality check script, and Go init runs automatically before the main, so the malicious code executes before any legitimate checks. Every successful attack dropped the same core payload, a curl of a hack mult repeat /mult bash delivered through different injection vectors, branch names, file names, scripts, and workflow parameters. How they were hit. So I'm not going to read this whole thing. Maybe I'll do that for the podcast. But yeah, the HackerBot Claw campaign provides an autonomous agents that are actively hunting for CI/CD misconfigurations at scale. So this isn't new. Like, this may have been all AI done, 4 or 5 months ago, but it sounds like they're not trying to hide the fact that this is AI motivated here or AI written. And basically never run forked code in Bash with unescaped. I mean, basically never run forked code of untrusted repos. So we're going to talk about that. Avoid the pull request target. That's always recommended. That has been for a long time now. And GitHub is slowly locking down the pull request target, trying to not break existing workflows while also trying to protect people. I think I'm going to sneeze. Maybe not. Just kidding. All right. Lock down AI-powered workflows with read-only permissions. Right. So, absolutely. If you've got AI in your workflows, I guess that's now a new vector, and it's not specifically to GitHub. It's not a unique thing to GitHub, but maybe we should put that on the list. So LLM prompts in actions that look at untrusted input. Yeah. Generally, that's just a bad plan on the entire internet right now. If you have anywhere where someone can put an untrusted set of prompts in an LLM and it can actually execute code as a tool, then you're going to be in some trouble if you're letting anybody do that to your code. So, and then continuously scan workflow files for dangerous patterns and over-privileged token. Okay, so this one's a little more nuanced. Exactly how of course, this is actually because this article is written, I believe. This is written because this is written by a company that sells a product that will scan your GitHub for security. So, this is from Step Security. So they have a platform that actually will monitor your GitHub and look for these things. I think everyone can do this for low cost or free. Like, this isn't. It's knowing where the things need to be scanned, right? And that's the real knowledge, not so much the act of actual scanning. I don't know why I need to. It's not highlighting. Highlight. All right. So we're gonna walk through each one of these and what they look like. So the first one, and to back up, what has been happening is essentially a right combination of settings from that list, right? The right combination of settings from this list means that a stranger, someone who's not given permissions specifically in your repo, can fork your repo, make a pull request back to your repo, and then run their code automatically in your GitHub Actions. That's a scenario. There's multiple ways for that scenario to happen, and it never should happen. And there's no quick built-in warnings when you accidentally enable this type of attack. And it's not even obvious when you enable this kind of attack. So I think at this point, if everyone doesn't have some sort of scanner that is looking for these bad behaviors, I'm not even sure the current linters, like the action lint, which is what everybody uses for GitHub Actions, I'm not sure action lint will catch all of these. It does do some security warnings, and there are a few other ones that look for patterns. We can talk about those. If you have questions, throw them in chat. I'm happy to dive down into the deep details of any of this stuff. If you think something affects you specifically, throw it in chat and I will cover it. But the first one is simply avoiding this event. And the way we do that is in all of your GitHub Actions. So your GitHub Actions all exist inside of .github/workflows. And if I look at one of these, and we just zoom in. So this is an event. Line 4 is an event. These workflows, or this is really just code. This code auto runs based on events. And there's a lot of events emitted by GitHub. There's dozens of them. And certain of those, there's actually more events in the API than there are in Actions. Actions can do things based on a subset of the events of the GitHub API. But one of them is, hey, you open up a pull request. This is actually overloaded. It's not just I opened a pull request. It's I made a commit on a pull request. So anytime I make a commit to a branch that's in a pull request, this event will fire. And this is probably one of the most common ones because most of the stuff we're doing in GitHub Actions either runs on a schedule or it runs based on a pull request commit or it runs on just any commit. So to me, those are the three most popular versions. Workflow Dispatch is probably the fourth most popular, and Workflow Dispatch essentially means manual running by some external event. That external event can be a human clicking a button, or it can be someone webhooking essentially into your repo who has permissions, that specifically requires permissions. But the pull request one in particular implies that if someone's in a forked repo and they're submitting a pull request back to my repo, that's one of the few cases where an external non-trusted individual or bot, an account of some kind, can change something in my repo or offer a change to something in my repo. Technically, you could fire off events on creating a comment or creating a GitHub issue or creating a discussion or doing other things in a repo that the public might have access to. If you're an open source repo, you're probably allowing people to file issues. You're probably allowing people to file pull requests or to create a discussion or a comment on an issue. Any of those things are technically an event. They're a change or a potential change. And the pull request is honestly the most dangerous one, but this alone isn't enough. Just simply putting that there doesn't mean you're at risk. It's this one combined with a few other things. So this one combined with a setting, and if we go over to Actions General, this is where the settings for GitHub Actions are. And one of the settings that I love to pick on is this one right here, approval for running forked pull request workflows from contributors. This means this is only going to apply when the branch that they are submitting to the pull request is from another repo, okay? Not the repo itself. So most teams that I've found that I work with, not all teams, but most teams I work with, they're making branches in repo. If they have a closed source or an open source repo, they're doing their work inside a branch. On occasion, they might fork it, but the team might have a policy where they don't even allow forking. They don't want forking. They want you to do everything there. In open source, though, the only people that typically have access to the repo to write branches are maintainers. So how do you get external contributions on an open source repo? The answer is forked pull requests. So this is really, and especially in open source, coming from untrusted people. The default setting is this. And I believe this should be the default setting. This is what's getting people in trouble. This actually goes back a little bit to the long game. So that's this second one right here, social engineering being the default external contrib setting. So this means if that default is still set, if this setting right here is still set to that default, all someone has to do is get one PR accepted. Maybe they do a friendly README change. Maybe they do, maybe they submit a quality piece of code to fix a very small issue. And so you see their pull request. It's not auto run because it's their first time. So those pull request workflows, like the ones I had here, I'm just going to separate them out. No, he's fine, but
You didn't take him out?
no, I didn't. But if I go over here and I just go to a workflow and pick on it, Anton, what's up? Our company decided the easiest way to prevent all possible GitHub Action attacks is to have no GitHub Actions at all. We moved away to on-premise solution, so now we are in completely isolated, controllable environment. Nice. Yeah, the challenge with GitHub Actions isn't that they're inherently insecure. It's that engineers maybe don't. There's a lot of foot guns because especially if you're in public repos. I would say in private repos, the risk is just about as common as any other cloud offering is at equal risk of private repos. But I don't know that we've ever had. This is probably not true, but I don't know that we've ever had recently in the years that I've been paying attention. I don't remember an attack that was successful on closed source repos unless they first successfully attack and own essentially one of your open source repos. And then they might be able to get, this all depends on your security posture, but they might be able to get a secret that you've stored in that repo that also has access to private repos. There's all sorts of levels to this where if you just make one bad decision, then other things are vulnerable. And it doesn't even have to do necessarily with GitHub Actions, anywhere you store secrets, right? So, technically, if someone's able to, there's probably all sorts of scenarios where even an on-site solution is at risk, where someone gets into something you have on the internet and then they're able to get a secret that then gets them into the internals. But I would say, yeah, having just by the nature of having things internal might seem more secure, and I think there's probably less foot guns in that approach. The thing that I worry about internal stuff, though, is internal stuff typically doesn't get the security review that it deserves. It kind of is a little more fly by night. So then people get a little lax, and then they start putting in sort of administrator keys or secrets that have full access to everything. And all that takes is one bad NPM package, and then suddenly their secrets are exfilled anyway because they're coming through your supply chain. And that's one of the challenges here is the unfortunate fact is right now, all these open source projects misconfigurations in their own open source is affecting the rest of us, because then what happens if the attacks are successful, like they have been last year with Shai Hulud, tens of thousands, I think at this point probably hundreds of thousands of developer accounts were attacked on GitHub, not because of their own fault, but because of one open source repo in NPM that was successfully attacked. Then a vulnerable piece of code was uploaded to NPM, and then anyone running NPM on their local machine was attacked through that NPM, and then their local keys were put publicly on their GitHub account by a local virus, essentially. And then all their keys were available on the internet for the attackers to scrape and then use those keys anywhere they wanted to. And this was happening like in September and November timelines. I think it was happening to hundreds of accounts, if not thousands of accounts every hour. And that had nothing to do with anyone's personal security, unless you want to argue that your local secrets need to be scoped, which very few developers actually do that. Like they just want a key that's God writes that gives me access to everything. So I put it locally on my machine because it's safe there. But then an NPM package that you happen to have in a bunch of your repos because it's very popular, or a bunch of your code, suddenly makes you vulnerable to attack. And I feel like it's very hard to prevent at least in our security posture as an industry, it is very hard to protect against that. We don't have antivirus solutions sitting on our machine looking for nefarious NPM code that might exfiltrate stuff to the internet. It's almost like we would have to have a firewall that blocks code running in our shell on very specific paths, like NPM paths or code paths, like to have those prevent exfiltration. Nothing can make an outbound connection to the internet. And that's going to be very hard when you do NPM commands all day long, which do the exact thing, right? So even a firewall, like you would have to approve a firewall allowance, which there is Mac and Windows firewalls that will prevent this, but I don't know anyone who actually does that because it would literally require you to approve things every time you type commands at the command line. So it's a very tough situation I think we're all in, and we have to be productive. And I think the most successful security is security that's on by default and that it doesn't require you to go through a whole bunch of hoops. I get annoyed just by having to approve my SSH keys to git push, which every time I want to git push, at least like once an hour, I have to approve one password, whether it's on my watch or something, I have to manually approve it. And that annoys me. And I try to stay super safe. Like a lot of my friends don't, and they just YOLO everything. But I try to keep my things locked down, and I'm annoyed by it. So I sympathize very much with people that are vulnerable to these systems because it's hard. Like all of this is really hard. So we need to do more. We need to advocate more for education and proper shutdown or proper locking down of these repos. So maybe less open source will get hacked and we'll be at less risk. All right, getting off my soapbox. Back to this. No, we don't want to go in here. We want to go into workflows. Let's just do this one. So this one's got a workflow dispatch and a schedule. So it doesn't have the pull request. Let me pull up this one. Okay, so we have the pull request here. So what should be the considerations to move? What should be the consider actions we have to move? Hey, 337. Or eat. Is that are we lead speaking right now? Are you eat? At eat. We have an on-premise Jenkins, so I wanted to ask so I can have a brief idea. Well, one, there is a converter for Jenkins pipelines to GitHub Actions, so that's nice. GitHub builds a converter. Just look up GitHub Actions converter Jenkins, something like that, and you'll find a repo. So that'll help you at least try things out. GitHub is very repo-centric and very code-centric, where Jenkins is much more general. You can do anything you want in Jenkins. You can have it run a pipeline that installs Windows servers in your data center. Like it can just do anything you ever wanted it to do because it's really just going to run code. GitHub is technically the same thing. You can technically do that with GitHub Actions, but GitHub Actions is really its sweet spot, and its focus is automating code and repos. So if you have a bunch of stuff on GitHub, on Jenkins that is more maybe infrastructure focused or it's more deployment focused, that GitHub Actions can still do all of that. It just might require you to jump through a few hoops to do that. It maybe doesn't have all of the best features for that or the best plugins, but it's getting better all the time. And one of the things that I've been talking about in my posts, whether that's on LinkedIn or in my newsletter, is like GitHub is steadily improving things. And so that this posture could change in the next year. Me personally, the first thing I would do if I had Jenkins is I would start moving my linting and my build and test stuff, specifically when people make commits to a repo, move all of that into GitHub Actions. One repo at a time, one workflow at a time, do it slow so that you're not upsetting the apple cart. But that's the sweet spot. There's all sorts of other automation it can do, and at the end of the day, everything Jenkins can do, pretty much it can do. It's just a question of, does it make sense to put that in GitHub Actions? GitHub Actions has runners, just like any other CI solution. You can put these runners anywhere. You can use the free ones that come with GitHub, and there's a lot that you get for free. And the way that you pay for GitHub Actions is through minutes of use on their runners that they host. So if you use your own runners, at least for now, those are free. And you can put those anywhere you run and they all talk back to GitHub Cloud, or if you run GitHub on-prem, you can do it on-prem. But yeah, so that's, if you have specific questions, throw them in. But that's my 3-minute explanation, maybe. But as long as if you're doing stuff in Jenkins that isn't related to GitHub repos, like if you're not even using GitHub, well, obviously you wouldn't use GitHub Actions. Like GitHub Actions is designed for code on GitHub, and it can do other things on your repos. It can manage your repos. It can manage your organization. It can do automation about everything you do in GitHub. But its real sweet spot, because every workflow has to be stored in a repo, its real sweet spot is when you want to do infrastructure as code and you want to lean into the whole pull request process for all the change management of your code, your infrastructure, your YAML, everything else. And that's where maybe Jenkins is a little different, because Jenkins doesn't care. Jenkins doesn't really care where you store your code. It's agnostic. It doesn't even care that you store it in a code repo. You could just put files on a file server. You could put things in a S3 bucket. It doesn't really care. You could hard code stuff manually into GitHub jobs themselves. You can just sort of loosey-goosey it all day long with Jenkins and actually design a really bad system that way, right? You could design a very fragile system. It's not easy to back up. It's not easy to scale. Like, that's the challenge with Jenkins, is there's lots of ways to do it wrong, and there's lots of bad behaviors because it's really just a fancy automated code runner. Here, I have to put these in repos. So these repos all have to have these workflows here. They all have to be in this specific directory, and they run based on GitHub events and also external events. You can do webhooks and force things to happen. But if you're not going to do anything related to GitHub with the code that you're going to run in these things, just leave that in Jenkins, because here is the sweet spot, is doing things on GitHub. And the security problem we have right here is, in this scenario, getting back to our contrived scenario, is if you leave this at default in the settings, require approval for first-time contributors. The hackers now know this setting exists, and they know that this is the default, and they know that almost no one changes it. So what someone will do to your open source, again, this is all about open source right now. If you have an open source repo, someone will play nice. If they're playing the long game, they'll play nice, offer you a pull request that's legitimate. You approve that first pull request to run actions, because this setup right here means that if I submit a pull request to you, if I submit my code change to you over here in a new pull request, then let's say I did this one, or this one right here. Let's say I submitted this pull request. And in this pull request, I forked your repo. I made some legitimate changes. I submitted them back to you. And this isn't going to run any actions by default, because it's safe by default. It's safety. I don't want to run whatever you gave me. I don't trust your code. I don't know who you are if I'm the manager and maintainer of the repo. So you submitted it to me. I'm not going to auto run it. But the first time I approve this, I still don't know who you are. Maybe you're a complete stranger on the internet. That's the nature of open source. So the open source maintainers typically will look at your pull request they will be eagle-eyed in looking at your changes the first time, because what they really have to do is they're going to come down here, and none of this will have run. None of these automations will have run, and they're going to have to manually approve it to run the first time you've submitted that pull request to me. That's a safety feature that's on by default. So at least the first time it's safe. The problem is now you're on the inside. Once I've approved that to run, I have merged your pull request, which means I've accepted your change. This setting means that I've now allowed you into the secret group of people. It's not really a public group, I don't think, although someone could just analyze your repo for external contributors that have had accepted commits. And if I did that, then I could sort of work out which accounts are allowed to basically auto run. But when I do this, that means your second pull request will auto run any changes in my actions. So all I have to do is you be nice to me one time, and then the second time you're now that's to me social engineering. That's like the definition of hacking through social engineering. I've established trust with you, and now I'm going to do something bad the second time. And the problem with this setting is that I, as the maintainer, I, as the open source maintainer, I don't realize that when I'm accepting when I say accept on this first pull request, there is no warning that says, notice that if you accept this now, you have a setting in your repo settings that is going to enable this particular user to now always be allowed to run all actions against their future pull requests. And that's a very dangerous, I think, a very dangerous precedent in open source, because we don't know individually everyone who's submitting changes. And I approve changes to my own repos all the time from people I have not physically met. And I don't know who they are. They might be a student. They might be just a very nice person on the internet that volunteered some open source to me, and I really appreciate that. They might be a bot. They might be an AI controlled by a human somewhere. It doesn't really matter, because I'm always going to review the code, and that's because I don't have a lot of changes. But on a lot of these open source projects, they don't always meticulously go through every line of code. And after the first time you've submitted your pull request and I've accepted it, I don't get a chance. I have no opportunity to look at your code ever again before actions are run on it. And an action is just a code execution on this repo. Now, at least GitHub has a safe default here that in this case, your code will auto run, but there's not a lot it can do because it doesn't have access or permissions inside that second pull request. It doesn't have access to my secret tokens, because in this pull request, even in the first one or the second one or any future pull requests, you're still an external contributor, which means your code in an action will run in your repo, not on mine. It will technically run without my secrets, without my GitHub token, without anything that's potentially dangerous that I don't want you to have, okay? Now, here's the rub. If we go back to this list, if I had this event, if I went from pull request target as my event to pull request, if I went from pull request as the event to pull request target, that changes everything. Because now what that means is all those pull requests are going to run that particular workflow, the one that has this in it. That workflow will run with my secrets. Not your secrets, but my secrets, my GitHub token. Everything in my repo that's an environment variable or a secret now is going to run in the action against the code changes you're making without me first approving it, assuming you've had at least one accepted pull request. And that's the dangerous combo here. So if I have this set and I have pull request target on the workflow, we're in trouble. So this is why I always recommend everyone change this setting on every repo, always, essentially. I mean, I don't know why this shouldn't be set everywhere by default. And I don't even, in the current way that the UI is managed, where we don't have any awareness, we don't know that we're technically enabling some future privilege escalation. That's what I would actually call this. This allows privilege escalation next time. And there's no warnings. There's no indication when you're doing the normal work day-to-day of pull requests with external contributors. There's no way for someone to know unless they were to go and inspect this setting. So it's dangerous. This is I'm advocating to GitHub, please make this the new default. They've changed other defaults. They've changed this default before, where this was the default, which was, I think, a very dangerous precedent. It's now this is the default. I totally agree with that. I honestly think that the real new default needs to be none, not just read, but none. And I wish there was actually a setting here that allowed me to set none. I just simply can't. The only way I can do none by default is that I have to go into each workflow and manually set none. So again, another setting that there is no off by default allowed. This one, at least, we have the off by default, right? We have the require approval. And the way that you get around this, because an argument you might have with me is saying, well, how do I foster open source? How do I enable trusted external contributors that I know? And the answer is just give them permissions. Just put them in your repo permissions. Go into collaborators and add them. Like in this repo, I've added my friend Eric, who I trust with the code in this repo, and I've given him collaborator permissions. He's now considered a trusted maintainer of the source code. I could also put him in a contributor file, maintainer files. There's a code. There's certain files in GitHub that you can actually write into the repo to control permissions. I do like that approach even more because I feel like it's at the front end, because not everyone has access to this back end. So this is like the secret permissions layer that no one gets to see unless you're an org admin or a repo admin. So I do tend to like putting these things in files inside the code itself. If you're a security person, you might argue that I don't want anyone on the internet to know who might have the access, because then that just gives them a list of people to social engineer. That's also true. I don't know the right, so it's all depending upon your security posture, but I tend to like to codify things in ways where I can, if I put someone in here, no one else knows that this changes, right? There's an audit log, but no one reads those audit logs. So how do I change it if it's in code? Well, I make a pull request, and then people can review it and see that I'm making changes to the maintainers list. We could actually look that up. GitHub code maintainer files. Let's see if the, code owners and maintainers, also convention maintainers and authors. So if you go into the docs, they kind of explain these sort of special files in your repo that can actually control permissions. And they also give you way more granular control. Like they allow you to actually set permissions per directory. Really cool stuff. So I'm a big fan of that. But if we go back here to the actions, if you're only going to be on here for 2 minutes and you're like, what are the things I need to do, Bret? Just tell me the things, and I don't need to know the why, and I don't need to know the details. Then I would say, if you're going to hard code, if you're going to lock down GitHub Actions, you can actually just disable actions right here, like Anton did. Like that's a super easy way to really lock this stuff down. But then you lose out on all the advanced abilities of automation. So then you have to put your automation somewhere else in some other system that someone might attack. So it's up to you. I tend to, maybe if I'm going to go hardcore, and I personally don't do this myself, but if I was working with a team and we really wanted to lock it down, we would lock down this and say allow actions created by GitHub, allow verified marketplace actions, and then only allow actions from certain repos or organizations I trust. So you can lock it down that way. But the default is here. I think that this is like 99% of every repo on the internet is set like this, and I am not actually arguing for changing it. I would argue that you can enable this. This goes back to my silent rebuilds, which is a whole separate thing. If just look up Bret Fisher silent rebuilds if you want to know about commit SHAs and pinning to SHAs in both your Docker files and your GitHub Actions. That's a thing that we should all be doing. And so you could harden code that a little bit there. But the two settings you should always set up, assuming that you have GitHub Actions enabled, which they are by default, is you enable this, require approval always for all external contributors before I run. It doesn't prevent them from giving you PRs. It just prevents it from automatically running any stuff in Actions against my code unless I approve it first, which I think is a good thing. Any maintainer can approve it, but that's for all external contributors until they become maintainers. And then the second one is only allow read of the contents and packages in my repo. Don't give full read-write permissions by default. Give read only. Okay, so if you've done those two things, you're pretty safe here against almost every common exploit that's happening right now. Like, I think even if I had this and this, I still think all of these attacks would be preventable, even if they're using the pull request target. I'm not sure that I've actually tested this recently because they have locked down pull request targets more to make it even harder to exploit. But I have a feeling that my statement is true, that even if pull request target was there, an external untrusted contributor would submit a pull request with some nefarious code in it. And even though this pull request target allows them to run their code with my secrets, the code won't automatically run until I approve it, which means a human maintainer has to go in and approve that action run of those workflows that have this pull request target in them. And hopefully, if I'm a human, I'm reviewing the code, at least glancing at the code from an external contributor before I allow the actions to be run. Like, hopefully. So that's the one safety net there, is the human has to pay attention when they're approving the pull requests for running the actions. The other thing you can do is just avoid and prevent this from happening. I wish there was a way for us to go into settings and just have a little option that says never allow pull request target to be enabled. Because the main reason people use this, the main reason people add this in, is that they want external people who submit code to them. They want usually things like linters or other tooling in their repo to auto run. Maybe it's an action that will automatically triage their issue or their pull request. Or maybe it's a tool that will automatically label that based on what they've said, what they've said in the title and description. Maybe it'll auto label that stuff. And so these actions are sort of like they're organizing actions, or they're very easy automation. But in some situations, in order for those things to run, you need to give it a GitHub token so that it can do something else. It needs a secret, essentially, or it needs some sort of token. And so they add this in, not realizing the negative effects. And there are warnings in the docs. The docs thoroughly warn you. They maybe don't do it as a sort of simple explainer that I would recommend. I think they keep revising it. If we just look up pull request target in the docs, a lot of people are trying to help out. But if we go to pull request target, there's a note here, and then there's a warning. Warning, running untrusted code on the pull request target trigger may lead to security vulnerabilities. These vulnerabilities include cache poisoning and granting unintended access to write privileges or secrets. So it's one of those things where there should be some sort of scanner really in every GitHub organization that flags any time this shows up, because it's such a potential for misuse. It's probably, to me, the most dangerous event that I know of all 30 events that GitHub Actions can run on. Because it gives an external, it's the only one that I know of that can potentially give an external, untrusted user access to the secrets in your repo. And then they can exfiltrate those or do whatever they want with them. So if any team I was working with, this would be like one of my first big security talks. Is like, I wouldn't even talk about anything else. I would just say this feature alone is causing so much headache. It's still a risk on closed source repos. But the way that it's getting attacked is through open source repos. Once the bad guys figure this out, and they know they can just look in your files and see that you have that enabled, this is what caused the attack over the last week. So that's what, for example, they were able to get secrets that allowed them to delete the Trivy repo off of GitHub. And Trivy is a very popular, probably the most popular, or top 3 for sure, CVE scanners for code, infrastructure, Docker containers. I use Trivy. Trivy is always my default go-to. And especially when I'm trying to do things like scan a Kubernetes cluster or scan something locally. It's not necessarily always the best scanner in every use case, but it's a very popular one. So, and Aqua Security has been maintaining that thing for 7 years. And so there must have been in one of this, it just has to be in one repo inside your organization that's public that has that pull request target enabled. And combine that with the default settings of GitHub Actions. If you don't change those settings, those two things means that any external person can pretty much get secrets by just being nice once and giving you a pull request that you accept. And now they're given permissions to auto-run actions, which means with the pull request target that when they run their actions, it runs with your secrets, and they can run them anytime they want. And they can even run pull request against the non-main branch or the default branch. And I think that's actually the thing that GitHub tried to lock down. months ago, they locked down pull request target a little bit. So, yeah, this is November. And environment branch protection changes. So they're basically, some of the attacks last year that were happening on GitHub was people making pull requests to old branches, which wouldn't get attention, right? It's a way to sort of hide a little bit what's going on in that bad pull request, is they just submit a pull request to a branch that nobody cares about anymore, and they can run their code there silently where no one's really paying attention or seeing it, as opposed to pull request against the default branch or the main branch. So GitHub rightfully went and while this change helps enable, I don't want to read that. To prevent unintended access to environment secrets during pull request workflows, environment branch protection rules will evaluate against the execution reference, not the pull request head. I'll talk about that in a second. For pull request and pull request review and pull request review comment, environment rules evaluate against the merge reference. This matches the merge commit context for those events used during execution. This is all very technical stuff, right? Like, you're reading this and you have to really understand what Git is, how pull requests work, how branches really work inside of the Git tree. I mean, it's just, there's a lot of understanding that you have to know before you can even read these things. And then for pull request target, environment rules evaluate against the default branch. This is consistent with the updated GitHub ref and ensures policy checks occur against the trusted ref. I think I want to just, I want to see, I'm not in my AI browser. I want to copy this and see if AI can explain it like I'm 5. Is my, yeah, sure. Enable. What could go wrong? Okay. Please explain this GitHub change in a short paragraph, like I'm a junior engineer who doesn't know Git or GitHub. Let's see what it says. When a pull request is opened, GitHub Actions runs 2 kinds of workflows. The important distinction is where I said 1 paragraph. Jeez. Oh, Sonnet. It is not 1 paragraph. I am not okay. The bottom line for you as a junior engineer, if you have the environment protection rules set up like only main can access production secrets, this change makes those checks more consistent and secure. If your workflows suddenly lose access to environment secrets after this change, yeah, okay, it didn't really explain it like I was hoping. The major change that they did is that when someone submits a change to you in an untrusted way, like they're an external pull request and they're coming into your code and you have pull request target or one of these other ones enabled, then when the actions decides if it's supposed to run and what environment it might want to run in and what secrets it might want to give you, it's going to reference the security settings, not of what you changed, because you could just change the settings to say, hey, give me full access. Let me add pull request target as an event, and then we give full access to all the permissions and give me access to secrets and everything. And you could make that your pull request, and GitHub shouldn't be looking at your code to define the security of what that PR should run in. So it's going to look at the main branches before, the default branches before, basically for the security of that branch and that repo. It'll look at the existing code, not your changed code, because that way, no matter what your pull request sets, if it tries to loosen the security up of my repo, that won't work. That won't work because it's untrusted code, and GitHub should treat it like untrusted code, even if it's a change to a workflow. That wasn't always the case in certain edge cases, and so they're locking that down. I think they totally should. I mean, it actually seems like that's an obvious thing, but like, why would we trust any code coming into a pull request for the workflow? right? Why would we trust the workflow security settings? But the reality is, me as a workflow auditor, like a workflow editor, I'm going in and I'm making pull requests to change settings inside of GitHub workflows. And then when I do that, I need those changes to be tested in the pull request, which means I need those settings to run in the pull request. So it's a weird world where, like, I need GitHub to evaluate it based on the existing security. But if I'm changing security in a pull request, because that's the workflow for changing it, right? Like, the process we do to change security settings is create a pull request. So how do I change the settings and not test them without already committing them before they're tested? Like, it's a weird scenario. So they've got a hard problem to solve. I think, honestly, it should be based on whether you're a maintainer or whether you're external. I think if you're a maintainer, you're automatically trusted because you can write to any branch as a maintainer. And so if you have permissions to write to that branch already, I think that the evaluation of security should be based on that, based on you who's running it, not based on which branch it's going to or which branch. Anyway, it's just very complicated. I think really the way we solve this is through education in the PR. We need to have context and alerts inside of the PRs themselves that say, this PR is about to run actions with this person's permissions, and those permissions are this. Like, basically allow me to do an audit before I run an action. Let me see what permissions, what secrets is this going to show? When this GitHub action runs, what environment variables and secrets is it going to pull? Don't show me the secrets. Just tell me which ones it's going to show, because I'm not even sure sometimes when I'm clicking that button to run actions. I'm not sure what I'm giving this action. I might be giving it like secrets to my entire production AWS cluster. I don't know. So it's very hard to figure out in the moment, what risk am I really about to take if I let this run? And I think there's a lot of work we could do to sort of expose in real time and sort of have guardrails. Now, we should talk for a minute before we keep going. And Anton, I missed your comment there. But this won't help us if Eric's account is compromised. He still will be able to dump secrets. This is absolutely true. Like, there's no way, if you have, like, show me a system where that's not exploitable. So, like, okay, for one, if his account's exploited, like, to me, everything should be signed. All commits should be signed. Everyone in my team that I work with, it would be sort of a top-down organizational requirement that you have to have something like 1Password. You need to have two-factor on every push. And so we can enforce that with the humans, which means even if their password gets exposed to GitHub, there's a lot more things that have to happen before their code gets submitted. But you're right, Anton, like, if someone's account is hacked, no CI is safe at that point. Like, I don't see how that avoids, if you have a separate CI inside your organization, if it's keying off someone submitting code as a pull request, then they're just going to get the secrets out of your internal CI, unless that CI is somehow blocked from going to the internet, which most CIs aren't, because they have to pull down the code anyway. And so that's why, like, one of these attacks that came through NPM, that's why it would actually use your local GitHub, because it assumes that everyone's logged into GitHub locally, and it used GitHub to submit your keys, your secrets, in a base 64 encoded repo that it creates inside your personal account. And I don't even know how you would protect against that, because how do you prevent a repo in your personal account from getting created when you're already logged into GitHub locally? Like, there is no permission model where, at least I'm aware of, where you can give a local GitHub client access to do work on GitHub, pushing to Git and all that, but don't give me permissions to create new repos, or don't give me permission. It's a really hard system to set up. I think you would really have to be thoughtful, and you'd have to really think about all the different attack vectors there. But to me, once a lead engineer, a maintainer's account is exposed, if there's an ability for an external attacker to push code to any repo, CIs are usually kicked off by that repo, and those CIs are gonna have secrets. So at that point, those secrets are pretty much going to be exfilled. I don't see how Like, there's probably a way to do it. I just can't think of it off the top of my head. And if you have a way, I'd love for you to put it in chat, because that's something that I don't recommend people just put CI internally simply because that somehow protects them. In a lot of cases, external CI runners inside your organization are very common, and every organization I work with already has runners inside all the places because they need to run workflows against certain databases in production or have access to certain things in staging. So they put runners everywhere, whether that's running through an external CI or GitHub Actions itself. I'm not sure how that matters, because essentially they put code in to the, if they can have access to your repo, they're going to put code in that's then run on those runners and then is going to look for secrets in all the common places in the .envs and in the .config directories and all the common places that are going to have, Docker and npm and Git secrets and, database keys and all that kind of stuff. It's going to search for those, look for pattern matching, and then it's going to try to find a way out. And I very rarely see CIs that are so locked down that they can't get to GitHub or GitLab or Pastebin or any other website. Like it's a pretty hard setup, and it's so rare that I've never seen it. I think that it's honestly at this point, like those are the things that everybody should be doing, but nobody's doing it, and that's the hard work of CI teams that have to constantly struggle. And this is where I really sympathize with the engineers responsible for the build systems and the CI systems, because everything they try to do to lock stuff down inherently will negatively affect some human. And then they have to, and because of that, it's going to add a step in your workflow. It's going to add the requirement for you to sign stuff. It's going to mean that you're going to have to manually approve things, or you're going to have to open up 1Password prompts, or you're going to have to re-sign in to things every day because of security. Like, you're going to put burden on the developer, and you don't always win those arguments, or those debates, I should say, not arguments. And so I try to work, that's why I try to always befriend the DevSecOps team. Like, I try to be very good friends with the security team, because I want to implement their security requirements, but I also want to make sure that it's well designed. And, security teams sometimes just issue decrees, and they don't try to work to find a happy middle ground as much as they should. And it's maybe because they don't know. They're not savvy to the developers' workflows, so they don't realize what they're breaking. So me coming from the engineering side, I will try to friend everyone. I'll try to be friends with the database team, the security team, and the engineering team, and try to make sure that when I'm implementing these changes, like locking down some of these settings in GitHub repos, I will do a campaign, like where I go to the teams and I give them education, and then I do a Q&A session multiple times a week for like a whole month where we do lunch and learns, because I want to get these people on board with the changes before I change them. Otherwise, when I lock this stuff down, it ends up getting reversed, because I somehow will surprise people that maybe didn't get the memo or didn't read the email, and then they get upset. They tell their boss that production, these new features can't get to our customers because Bret's holding up production. That's what happens sometimes. And so then I get blamed, and then settings are reversed, and then I have to apologize. And so I'm always trying to get these people on my side when I want to lock these things down. But yeah, I think the way you help avoid those accounts takeovers is you really lock down things like signed commits and enforcing human policies, like that they have to use 1Password, they have to have 2-factor for every Git push. They have to really do some of these things that will prevent PATs from being exploited. There's some other things too that also will help, where if you, I showed this earlier, if you check this setting right here to require all GitHub Actions to be commit shot, it prevents some of these attacks where someone can sneak code into a public action. And this has happened before, where the actions themselves, because most of them are public, those actions themselves become the target. Someone changes successfully one of those actions, and then your code is now vulnerable because of someone else's action that runs in your code. And the way that you help avoid that is you require that all of your GitHub Actions have these commit SHAs. Let's go see what that looks like. So like here, this line has the action version, but I'm pinning to that SHA hash. So presumably I've determined that this one is safe. Presumably I've gone and at least looked at the code. I've maybe looked to see, how old is this commit? How many people are using this version? How many people have, what is the general quality level of this action? That's the kind of stuff you need to be doing all the time before you put something in your repo. This one is run by GitHub, so I don't necessarily trust it in YOLO mode of just like do everything. I don't care, change the versions any time you want. I'm not going to do that, but at least I'm going to pin because a lot of what ends up happening is that these actions will get exposed to some vulnerability that actually causes a commit, and they might even reuse the tag. They might reuse the tag version on the GitHub action so that the version doesn't even technically change, because you can reuse these tags for versions inside of Git. And that as long as I pin, they can't get through that barrier. They can't accidentally update code that's run inside of my repo. So I'm safe with this. This is, as far as I know, unless you're going to get a SHA hash collision, which is nearly impossible, this is safe. This code can't be changed. It can't be augmented. And I just need to do this on every single third-party action that I'm using. And then we go into those settings and we enforce it here so that they have to be set. So that's one thing to reduce, but that's only against external actions. That only prevents people mucking around with my actions. Doesn't mean that someone can't try to change this action to something different in a pull request and also have that run as a part of their new pull request. So any other questions on this topic? I think I've gotten through most of it. It's a lot, and every time I talk about it, I try to find an easier way to talk through these things. We've talked at this one a lot. We've talked about the social engineering a lot. We've talked about that, which is essentially the same thing. The LLM prompts, that one I don't have a good example for yet, but basically if you're throwing any AI, whether it's Copilot or you can just use a prompt. There's a bunch of LLM prompt tools inside of the actions where you can literally just type out a prompt. If you're doing that in a workflow that looks at anything provided in the PR, whether that's the code itself, or that's the title, or that's the description, or it's a comment, if you're doing that against the PR, then you're basically ripe for prompt injection. And so if you're not sending this through some sort of filter or sandbox or something that prevents that prompt from causing your LLM to do whatever they put. If they put an LLM prompt injection inside of the description of the PR, and then you have a workflow that auto runs on PRs to auto categorize them or, assesses what type of PR that is, or even it does a PR review, that LLM prompt is at risk of being injected with anything the external contributor puts in. And so this is something where I honestly, it's so complicated right now with whether or not these tools are going to protect against that, like whether it's CodeRabbit or Copilot or Claude Code, depending on which harness and agent you're using, it's hard to know whether you're vulnerable to that. So you just need to test. Like, I think if it was me and if I was going to pick a particular workflow and I was going to have an LLM prompt in it, I would try to prompt inject that workflow myself. I would try to see if I could, I want to put in a fake secret and a fake environment variable and see if I can't try some prompt engineering. And I don't even know I haven't tried this to the level to try to get myself in trouble with GitHub, because I'm not sure if GitHub is even searching for these kind of attacks. But I would try to see if I could get the LLM to do something nefarious against my code. Because GitHub has an action that they claim has proper sandboxing and that they're putting it through output filters that properly control what's coming out, and that there's no action taken based on the output, that only text. Like, they claim this is safe. I would, because I don't quite understand what they're doing on the back end, I need to trust but verify. So if I'm going to put LLMs into my workflows, which I think we're all at that point where we're going to start experiment. If you haven't already started to experiment with LLMs in your workflows, it's coming. That's why I'm making courses on it. Hey, did you know I'm making a course? If you just go to, did I have it up here? It's right here, right? This is it. Jump over to the wait list if you're interested in anything about GitHub Actions, whether it's AI or not AI. If you're curious about GitHub Actions, jump on the wait list. And when it launches, which we just announced some stuff to the early bird special insiders club this week. We're giving people access starting this week. So we're trickling out the invites and updates to the community. So if you're interested in some of this stuff, jump on the wait list and you'll get a free discount coupon when it launches. So back to this, back to the LLM thing. Yeah, I think this one is harder to understand, and it just requires testing. I think we should all be experimenting a little bit with this in our free time just to see what LLMs might be able to do for us and save time. I'm all about saving time and reducing toil with LLMs. So I want to trust but verify. I want to test and test and test even more with this stuff. But I'm at the point where I am willing to take the advice of the professionals. GitHub has recently released something called agentic workflows, where they claim that they have fully engaged the safety mechanisms and they have everything sandboxed, and they have all this filtering of the output so that there isn't a known way for you to prompt inject. But I'm always skeptical because I've seen enough reports of things that supposedly aren't prompt injectable keep getting prompt injected. So I would want to really further understand this a little bit. I would definitely want to test it and understand it at a deeper level. But this is a pretty interesting idea where in this case, what they're really doing is they're allowing you to create the workflows with AI. To me, that's a little bit different than having the AIs in the workflow, like actively taking things and putting prompts in to steps in the workflow. This works a little bit different, where you're actually creating the workflow with AI. And so it designs a really complex workflow with a special command called GitHub AW. And then it creates a lock file that it makes sure that the action won't change. And so then that action will run inside of your workflows later. It's a multi-step process, and it's a little confusing, I think, at first, because when you first read this, you think, oh, cool, it just really means it's going to have an AI running as a step inside of my workflow. And that doesn't necessarily mean that doesn't actually automatically mean what this is going to do. That's not necessarily what it's going to do. What's up, Corey? Good to see you. So yeah, I think that is a part of our future. This is basically going to become a module in the course, because it looks like GitHub. This all started a couple months ago in GitHub Next. Which GitHub Next is like the organization inside of GitHub that is full of smarter people, PhD people, researchers. So they launched this like 6 months ago. It's called Continuous AI. It's more of a thought piece on how we might do AI in CI, and they're calling it continuous AI. So it's almost like CAI. So we have CI, we have CD, and now we have CAI, I guess. I guess that's how they're trying to position this. But it's cool because they actually give you a list of some example areas that they're finding benefit for putting AI in your CI. So that's very helpful. These are areas where we can focus on that are maybe today things you either don't do at all in CI, or things in CI that are mostly human driven that you can maybe automate. So this is all going to be a part of my AI for CI course. And we're going to lean into the GitHub automations, the GitHub agentic workflows, and then also a lot of these examples, which they basically are implementing these with their agentic workflows. And we're gonna explore a lot of those in the course. Yeah, AI for collaboration, not just for individual productivity. So it's a pretty good piece. I'm gonna throw this in chat for you in case you haven't read it. It's like 6 months old, but it's still very valid on how GitHub is thinking about the future of AI in your CI. And then this is the latest outcome. So I would call that the thought piece. This is the implementation of that idea. And they have, do they have a list here? Yeah, so they have a gallery of different workflows here that you can take a look at. I'll put this in chat as well. And I think that's it. The one other thing that I was going to do today is work on this GitHub scanner, but I think I'm running out of time. I'm working on a side project. We all have side projects right now, don't you? Don't you have some Opus side projects? I know Corey does. So this is a side project. Actually, it's funny that Corey showed up for a second, but Corey actually helped me with this idea like 3 weeks ago, where I was talking through that list of checks. So this is Claude Code. I'm actually not in Claude Code. I'm using Claude, but I'm in Open Code. And it's a project I've been working on, actually really just for like an hour across the last 3 weeks, to build a tool that will scan for all of these things I've been talking about. And it'll be easy to run, and maybe it's a web service, maybe it's a CLI scanner, maybe it's both. Yeah, let's do this one. Which is a paid tiered feature. Oh, to call the GitHub API for repo level actions permissions, which is a paid tier feature. Okay, so it's telling me I need to give it a GitHub token, which I'm not going to do right now. So yeah, it's one of these things where like we could all just ask the AI to do it. But it's probably easier, especially in my courses, for people to just have access to some easy tools that will scan. Basically, to me, it's like Bret's best practices for GitHub security. That's really what this comes down to. And how can I automate that? So I've got a side project here. This will be finished at some point this year. I don't know when, but I'll be releasing this. And if you're on my newsletter, you will get notified when these kind of things launch. If you didn't know how to get on my newsletter, just go to bret.news. And this is essentially my newsletter for launching Corey has no idea how powerful GitHub Actions has become. With great power comes great hacking. Yeah, still diving in since our conversation. Cool. So yeah, for those of you watching, if you're interested in stuff like this, these GitHub Actions security things, if you're interested in my work and workshops that I have coming, we did a workshop in the fall around something called something called Silent Rebuilds, and I will send you this blog as well. So we did this big workshop that was combined with a repo of examples, combined with a blog post and an hour-long video that talks about how to ensure that your GitHub, inside of GitHub Actions, you should be running Renovate or Dependabot. Most people are running Renovate or Dependabot. Those are the two most common things for checking for supply chain dependencies, whether it's apt. Actually, well, it's probably not apt in Yum. It's everything but that. It's NPM. It's all of the language package managers and the framework package managers. But it also can do Docker files, Kubernetes YAML, Helm charts. It can do all those things. And one of the things that you need to be doing is you need to be checking, and you may not even know that this is happening, but the gist of this is that you need to be checking, if you're using any Docker files at all, that the images you put in your from line, those images are probably images you don't control, right? Maybe you're using the Python base image from Docker Hub, or any other image. Those images get rebuilt all the time, even without version changes. So we should all be SHA-pinning everything we can SHA-pin. NPM does this by default. Python doesn't do this by default, but it should. Lots of other package managers do this by default. And now this has come to Docker and Kubernetes and YAML and to GitHub Actions themselves. We talked about GitHub Actions pinning of each action. We talked about that earlier in the show. And you can now pin inside of your Docker files. And the way that looks, and we talk about it in this post, the way that looks is right here. So you can do a from node, and you can just SHA pin right there. And there are tools to automate this for you. Renovate and Dependabot will both automate this for you. But there's a problem, which is one, in that scenario, you don't actually know the version. So you can change it to this. This is better. You can change it to have the actual version in there as well, so that you, the human, can read the version. The computer will ignore that version and only go with the SHA pin. And so when you change it, that's what it'll look like when you update. And this is what it will look like every time. If you've got your Renovate and your Dependabot set up correctly, this is how your Docker file from lines will change every time. It'll change the version as well as the SHA hash, and that's the way you should do it. And you should enable Dependabot and Renovate to run daily. And what you'll notice is they will give you, this is where you talk about the largely unknown problem of silent rebuilds. You will notice right here that the SHA changed, but the version didn't change. That is a common trait of all popular open source base images, is that they get rebuilt for all sorts of reasons. Maybe they updated the underlying OS dependencies to reduce CVE count because the README was changed. Like any other reason to make a commit in a Git repo, that's why these things change. They change all the time. For, I'd say, most popular open source projects, there are anywhere between 2 and 10 rebuilds over the lifetime of a particular version. There are, I'd say, 2 to 10 rebuilds that change the SHA hash but don't change the version. That's the spoiler. And if you didn't know that was happening, it's been happening forever. We just didn't know it was happening. We maybe weren't paying attention to the fact that it was happening. But you need to be on the latest versions of everything, which means if you're going to reduce the CVEs and you're going to reduce the security risk of your images, you need to implement Renovate and Dependabot to always SHA-pin everything in a Docker image, everything in a Docker file, everything in a YAML file for Docker or Kubernetes or anything else, Python or Podman if you're using Podman, like Containerd if you're using Containerd, Nerd Control, like whatever you're using, you should be enabling this in your GitHub repos. And that way, you're capturing all the latest image updates, as well as, if you're doing Renovate and Dependabot, you obviously care about updates, you care about security. So just make sure you go to the repo that we point out somewhere. Is it at the bottom? Do I have it somewhere? Maybe I need to update this. Oh, find it in the repo. I need to make that more obvious. But in this repo, Silent Rebuilds, are all the examples of how to set that up. I give you an example for Renovate. I give you an example for Dependabot. And it's very easy. It's very few lines. And you can even throw in safety measures to say, hey, don't auto update to major versions because I want to do those manually. I don't want to update major versions of things. You can control all that. But if you do this and you run it daily, then your Docker files will get updates to the base images that can reduce your CVE count without changing the version of the product you're using, which to me is a win. Like that's a win-win-win that everybody should be doing because you don't have to evaluate it. I mean, you definitely need to run it through your testing, obviously. It's a change. All changes go through testing. But it's extremely low-risk change because it's not even changing the version, even the patch version of that Nginx, MySQL, whatever, Python version, whatever you're using inside of that image, right? So it's one of the lowest risk changes possible, but it often reduces the count of CVE vulnerabilities. And we did this analysis last year where we went through and we, Eric Smalling and I, we went through examples. This is Node, and we compared the number of CVEs for every version as that version changed. So you can see like this version 23.11.02, it had five different rebuilds of that exact Node version image. So the Node version didn't change, but the image did change. And it changed over the course of 20 days. And you can see that the vulnerability count changed. It went from, the first one was 161 high 40 critical vulnerabilities. Oh, it didn't change the critical. It reduced the highs from 161 down to 150, then down to then up to 154. So it's a moving target, but it does change the count of vulnerabilities. And of course, this all depends on when it was scanned. So this was all scanned on the same day. So I think that's how we did it. So we didn't, presumably older versions will have more vulnerabilities in them, right? But that's the thing is you don't know why these happen. You don't know why these rebuilds happen, which means you can't assume that they do or don't lower your CVE count. So you have to prepare for that. And my stance is any new rebuild of an old piece of software is a good thing because it's going to likely include more updated upstream software from the OS itself. More likely. Not always the case, but you can see here that a lot of these, like, Node version 24.2 was rebuilt 3 times, or technically rebuilt twice over the first build. 3 total builds, 2 rebuilds. And yeah, the same 40 critical vulnerabilities existed in all 3 of them. So that's the thing is you just don't know. You don't know what's going to happen. But that's the point is this stuff does happen. And if you're interested in any of that stuff, sign up on the newsletter as you'll get updates there. All right, everyone. Thanks for hanging out. Thanks for being here, Corey. Thanks for being here, Anton at 337 at eat. I think that's how, if I'm going to lead speak that name, or Ait, or yeah, I don't know how to say it. I'm struggling. And anyone else here, MF Tuna, it's good to see you all. I will be back next week. We may have a special guest next week. We're going to have Docker on the show this month. We're going to have a whole Docker episode talking about everything new at Docker over the last 6 months, 8 months, because they've been steadily releasing things like sandboxes and AI stuff, and we're gonna get into all of it. We're also going to have some people on the show, some more GitHub experts, possibly someone coming that actually works at GitHub on GitHub Actions. I'm excited about that. We've got some other people that are planning to be on the show, including a new GitHub Actions startup that's going to help automate fixing things inside of your GitHub, including GitHub Actions. So that's pretty cool. An AI automated fixer. It sounds like a great thing. That team is from Mindrel, and we're going to have them on the show. So stay tuned. Also, if you missed the show, a lot of these episodes with guests in particular, whenever I have guests on the show, end up on the podcast. You can see the podcast links below in the description, and I will see you next week on YouTube Live. Ciao, everybody.